The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered on the Howard College campus, agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are agricultural engineering, which is offered in Pietermaritzburg, and geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Centre showcases the college's scientific achievements and promotes the public understanding of science, engineering and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. The college has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centres within the college. The African Centre for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Centre for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Centre for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centres at the university, the Centre for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Centre for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of the transistor and the laser, and is currently being used to develop quantum computers and quantum cryptography. The college is committed to access and readdressing the disadvantages and inequities of the past. The highly successful Unite Engineering program and the Science Access Foundation and augmented programs offer alternative access to university, equipping students from disadvantaged backgrounds with the skills and knowledge to pursue their degrees of choice. Both these programs contribute significantly to advancing Black African scientists and engineers in South Africa. Staff and students contribute to a number of outreach and community initiatives that focus on social responsibility, sustainable development and upliftment of the wider community. The college also engages in activities involving the pursuit and understanding of science, engineering and technology through exhibitions, festivals and roadshows that target high school learners and the general public. The college has minimum entry requirements for its programs. These differ from degree to degree, but all require a national senior certificate and minimum performance levels in mathematics and either physical or life or agricultural sciences. For those who do not meet the minimum requirements, access programs are available. Additional information and brochures can be obtained from the contact information accompanying this video. The College of Agriculture, Engineering and Science is proud of its contribution to the university, the region and the country.
UKZN is one of the best. I definitely understand it's one of the best in South Africa. So for me, there was no other institute that I would have preferred other than UKZN.
We have the best facilities here in terms of laboratories, in terms of equipment, in terms of human resources, in terms of literature.
UKZN is one of the best universities in the country that teach agriculture or natural sciences.
What I think is good about this college is the level of international collaboration that we have. We have friendships with universities all over the world, which means that we're keeping up to a great international standard.
UKZN has got much more facilities and it's recommended worldwide to do your science studies here. Life begins here. Yes.
We continually strive to be academically excellent, innovative in research, and critically engaged with society. We invite you to join us or work with us to be part of this exciting team.
You can take over, Rachel. Okay, thank you.
Hello everyone, today we're going to be going over sequences and series. So basically throughout these sessions, each session is going to have a different topic from the Matric curriculum. So today we're starting with sequences and series, then we'll be going on to functions, finance, etc. So we'll be able to cover everything in the syllabus throughout these sessions. Okay, so to get started, today we're going to go through arithmetic sequences, quadratic sequences, geometric sequences, and then arithmetic and geometric series, and sums to infinity. So let's get started with arithmetic sequences. So these are the most basic type of sequences you can get. So as you can see, it's for example, minus 15, minus 11, minus 7, etc. And if we just take a close look at the sequence, we can see each time we are adding 4. So minus 15 plus 4 is minus 11, minus 11 plus 4 is minus 7, and so on. So that's basically the characteristics of an arithmetic sequence. Right, we have a first term, for example, 15, and a common difference. So if we look at the first term, it is the first term plus 0 times the common difference, because it's the first term. We don't add anything. Then to get the second term in the sequence, we need to take the first term, which is just A, and add the common difference. Then to get the third term, we're going to take the second term here. So you can see it's A plus D, and add the common difference again to get A plus 2D. And now we can kind of see a pattern forming. We always have A plus some number of the common difference. So basically you can see here's term 1, and it's times 0 common difference. Here's term 2, we're timesing 1 common difference. Term 3, we're timesing 2 common differences. So the general form for an arithmetic sequence is, so Tn, that's the number of the sequence, for example, 15 or minus 11, is equal to the first term plus n minus 1. This is the position. So for example, 15 is the first term. So its n would be 1. So first term plus n minus 1 times the common difference. And intuitively, we know the test for an arithmetic sequence. We need to check if there's a common difference between any 2 consecutive terms. But in order to do this and write it out mathematically, we can do this. So D, the common difference, is equal to a term minus the term directly before it. So that could be T2 minus T1, T3 minus T2, T4 minus T3, etc. until the last term minus the second to last term. Okay, so now just to consolidate all that information, I'm going to go through a quick example. Please feel free to stop me at any point if you have any questions. Okay. Here we go. So our example question, we have a sequence, minus 15, minus 11, minus 7. And the sequence continues until the last term, which is 173. So sometimes we're given a last term, a Tn, and sometimes not. So it just depends on the question. So just to show the difference between Tn and n, right? Tn is the value of the term. So 15 is T1. The term value is minus 15, minus 11, minus 7. But it is at position 1. So this is n, and that's Tn. Okay, so the first question is this an arithmetic sequence? And the way we're going to do this is by comparing 2 of the terms. Okay, so let's find T2 minus T1. So that is minus 11 minus 15. And we know this is going to be 4. Okay, so this is D, the common difference, but we don't know if it's common yet. So we have to look at another pair of numbers. So let's take T3 minus T2. That is going to be minus 7 minus 11. And that is going to equal 4, which is the difference. So as you can see, the difference between T3 and T2 and T2 and T1 is the same. And that is our test. And so we have proven that this is in fact an arithmetic sequence. And why is that? Just to reiterate, it is because there's a common first difference. So now that we know it's an arithmetic sequence, the next thing we need to do is find the formula of the general term. So now we're going to look at this formula that was given. Let's just write it down. So Tn is equal to A, which is the first term, plus n minus 1 times the constant difference. So now that we've written that down, we can start filling it in. So this was given, and we need to look for the first term. So it's this one, the first term that is shown. So we're going to sub that in to A. And we've already figured out what our constant difference is from question 1. It is 4. So we can just substitute 4 in there. And now all that's left to do is just multiply it out and make it look a bit neater. So what we end up getting is 4n minus 19. So that is the general formula. Okay, and then question 3 asks us to find the value of the 7th term. So we want to find, when we substitute in 7 into here, what is the value of the 7th term going to be? So let's just write out our formula again. Then we're going to substitute wherever we see n, we're going to substitute in 7 for the 7th term. So T7 is 4 times 7 minus 19. So T7 is going to be 9. Okay. Next, we are determining the number of terms in this sequence. Okay, and we know the number of terms is going to be whatever number term this is, because this is the last term value given to us. So once again, we're going to write down the formula of the general term. And we want to know what position in the sequence this is. So we're looking to find n, because we already know that the value at the last term is 173. So if we substitute that in, all we need to do is solve for n. So we're going to take the 19 across. So 4n is equal to 36. Oh, wait, sorry. For n is 192. Okay, since we're adding, and then divide by 4 will give us that n is 48. Okay. So that means that there are 48 terms in the sequence. Do we have any questions so far? Okay. So that is arithmetic sequences. Next up, we have quadratic sequences. So these are a bit more complicated because it is not the first difference that is common. The first difference changes, but the second difference is constant. So that's how we check for quadratic sequences. So a quadratic sequence of numbers is a sequence of numbers whose second difference between any two consecutive numbers is constant. And here is the formula for the general term. Tn is equal to an squared plus bn plus c. So to test for quadratic sequence, we need to find the difference between consecutive terms. So in this example, we found the difference between each of these plus 1, plus 2, plus 3, plus 4, and then find the difference between those differences. So the second difference. And as you can see, it is constant at plus 1. Okay. And sorry. And now we're going to illustrate this with an example. So we're given a sequence 1, 4, 8, and 13. We need to check if the sequence is quadratic. So we're going to use the test for a quadratic sequence. So first of all, let's find the difference between each of these consecutive terms. So between 1 and 4, we have to add 3. Between 4 and 8, we add 4. Between 8 and 13, we add 5. So as you can see, this difference is not constant, so it cannot be an arithmetic sequence. So we need to find the second difference. So the difference between plus 3 and plus 4 is plus 1. The difference between plus 4 and plus 5 is plus 1 again. So here we can see there's a constant second difference. And this means that we, in fact, have a quadratic sequence. Okay, so that's the first question done. Then the second question is, what is T0 of the sequence? So what's given? The first number in the sequence is always T1. That's T2, T3, T4, and it continues on. So now, what if we work backwards to find out what T0 is? So let me just write this out again. So we don't know what that is. We know the difference is plus 3, plus 4. I'm not writing everything out, just these two. Okay, so now we need to work backwards. So as we can see, the first difference goes plus 3, plus 4, plus 5. And if we work backwards, so we take plus 3 and minus 1, we know that the difference between T0 and T1 must have been plus 2. Okay, and then as you can see here, plus 2 plus 1 gives us plus 3. Okay, so we can just convince ourselves that that is correct. Then we need to work backwards again. So 1 minus 2 is going to give us T0. So 1 minus 2 is minus 1. Then if we work forward, minus 1 plus 2 is 1. So we know that we are correct. So we can say T0 is equal to minus 1. And now we're going to give the next 2 terms of the sequence. So we need to find T5 and T6. Okay, so we're going to take 13, that's the last one we know, and add 6. That's going to be 19. Now we've just added 6. So to this next term, we're going to add 7, which is 1 more than 6. So we get 26. So those are our next 2 numbers in the sequence. Now we need to write out the formula for the nth term. So the reason I worked out T0 here is because T0 is actually C. If you remember, Tn is equal to an squared plus bn plus c, right? So if we substitute in 0, so T0 is equal to a times 0 plus b times 0 plus c. So then from here we can see that T0 is just c. So now we already know one of the variables that we're looking for, c. Next is a little trick. So 2a is equal to the second difference here. So it's equal to 1. Then we just take the 2 across. And a is equal to a half. If you don't remember that, then you can always just substitute, for example, T1 and T2 into Tn and just work it out simultaneously. Otherwise, just use this little trick here. Now that we have A and C, we can just substitute T1 in and solve for B. So we substitute in half, 1 squared plus B times 1 plus C, so minus 1. So T1 is 1, so we're going to substitute that as well. Then we get a half plus B minus 1. And if we take everything to one side, we get 2 minus a half is 3/2, or 1.5. So now we have our values for C, A, and B. So if we just fold this into our general formula, we'll have our answer. So half n squared plus 3/2 n minus 1. And now if you're not too sure, if you made a mistake along the way, you can take out your calculator and just substitute in T3 or T1 or T2, just to convince yourself that you've done it correctly. So I substituted in 1, and so for T1, and I got the answer of 1. So I'm happy that this is correct. Okay, So that is quadratic sequences. Next up, we have geometric sequences. Okay. So now instead of a common difference, we have a common multiplier. So when we start at term 1, we're just going to have our first term. To get to term 2, we need to multiply it by something, some r. And then to get to term 3, we take term 2 and multiply it by some r. So as with the arithmetic series, we can kind of see a pattern. We have ar to the 0, so 1 minus 1. Then for term 2, we have ar to the 1, which is equal to 2 minus 1. Then for T3, we have ar squared, which is 3 minus 1, yes. So then for a general term, we have this formula here. Tn is equal to a times r to the n minus 1. And then to check for a geometric sequence, we're just going to use this formula to check if there's a common ratio between any two consecutive terms. So use this formula, take any term in the sequence and divide it by the term that's immediately previous. And if they are all the same, then you can say that it is a geometric sequence. Okay, so an example, we have 2, 4, 8, 16, 32, and so on. We can see here, we get from 2 to 4, timesing by 2. We get from 4 to 8 by timesing by 2. 8 to 16 by timesing by 2, and 16 to 32 by timesing by 2. Okay, so that way we can see that it is a geometric sequence. If you wanted to use the formula, we would just go T2 over T1 is equal to 4 over 2 is equal to 2. And then we could do it for any other pair of numbers. So let's go with T5 and T4. Is 32 over 16, which gives us 2. So we can see there's a common ratio. Okay, so on to the actual question. So this sequence is the number of new people invited to a party each day. So on the first day, 2 people are invited. Then on the second day, 4 more people are invited. The third day, 8 more people are invited, etc. So we need to calculate the general formula. We can immediately see that A is 2 because that's the first term in the sequence. And we already know R, we worked it out here. It's 2. Okay, and then all we need to do is substitute it into this general formula here. Tn is equal to AR n minus 1. Okay, so let's do that. It's 2 times 2 to the n minus 1. And if you want, you can simplify that to 2 to the n. Right, because you can see 2 times 2 to the n minus 1 is equal to 2 to the 1 times 2 to the n minus 1. 2 to the n minus 1 plus 1 is equal to 2 to the n. Okay. Now the next question asks, how many new people are invited on the 10th day? So the 10th day is the 10th term in the sequence. So we just need to substitute in 10, so 10 days. So T10 is equal to 2 to the power of 10, and that is equal to 1024. Then the next question asks, on which day will 16,384 new people be invited? So we need to know which day, which term is this? So we're looking for N. So all these people were invited, and it's equal to 2 to the N. Okay, and then so from here, you can just grab your calculator, type in 16384 equals shift factor, and we can see it is 2 to the 14. So we get 2 to the 14 is equal to 2 to the N. The bases are the same, so we can just drop them, and we get 14. So on the 14th day, 16,384 people were invited. Okay, do I have any questions about sequences so far? You can drop them in the chat or unmute yourself and ask. Okay, so carrying on, we are going on to series now. So this is similar to sequences, but instead of just listing them, we are going to be adding them. So we just basically, all we need to do for these questions is find out what we're substituting and what we need to solve for. So we have, for an arithmetic series, we have this sum. S stands for sum of n number of terms, right? So it could be 1 or 2 or 3, etc. And it's equal to n into 2a plus n minus 1d all over 2. So we know, just a reminder, a is the first term in the sequence. D is the constant difference. And n is the number of terms we want to multiply. Add up. So this is the number of terms to be added. Okay, so now we have an example question for arithmetic series. So we need to find the sum of the first 30 terms. So immediately we can see that n is equal to 30. Because we want to sum up 30 terms, that's our number of terms of an arithmetic series, and that tells us we're using this formula with Tn is equal to 7n minus 5. Okay, so from here, Tn is equal to 7n minus 5. If we substitute in 1, we'll be able to find a, the first term. And from here, we can also see that our common difference is 7. So d is equal to 7. When we substitute in 1, 7 times 1 minus 5 is 2. So A is equal to 2. And now we found out everything we need to. So note how it says find the sum. So we're solving for this Sn here. So Sn is equal to n into 2a. It's always good to write the formula out first, because most of the time you will get a mark for writing out the formula in full before substituting anything in. So there we go. And all we need to do now is simply substitute in these values that we found. So n is 30, 2a is 2 times 2, plus n is 30, so 30 minus 1 times 7. And once again, it was all over 2. Okay, and then substituting all that and putting it in the calculator. Should give us 3,105. So that is arithmetic series. Next up, we have geometric series. So this is a sum of a geometric sequence. So we know there's going to be a common ratio, and we need to find the first term. And as you can see, we have 1 minus r on the bottom here. So we just need to keep in mind that r cannot be equal to 1, because then we would be dividing by 0. Okay, so let's take a look at this formula in action. We're given a sum. So we need to calculate the sum from k is equal to 1 to 6 of 32 times a half to the k minus 1. So this might look a little similar. To this formula here. We have a times r to the n minus 1. In our example, we have a times r to the k minus 1. So instead of n, we just have k here. So from this information, we see that a is equal to 32. Okay, because this is in the form Gn is equal to a r to the n minus 1. So we're just going to pick 32 out from there. Okay, then we can immediately see r as well. So r is equal to a half. And then n, if you know what the sigma means, it means a sum. So it's basically summing when k is 1, when k is 2, 3, 4, 5, and up to 6. So this is a 6 here. So what's going to do is it's going to put in k is 1, going to remember that number, it's going to add k when it's 2, k when it's 3, etc. So that means it's going to add a total of 6 times. So we're adding 6 terms. So n is equal to 6. Just in case it's a little bit difficult to see, this is what the question is. Okay. So now we have all the values that we need to just substitute and find the sum. Okay, so Sn, that's the sum we're trying to find, is equal to A times 1 minus R to the N over 1 minus R. And we just need to substitute these values in. So 32, 1 minus a half to the power of 6.
Hi, Rachel. There's a question in the chat. Someone sent me a direct message saying that where did the comment difference 7 come from?
Okay. Okay, so if we go back to the arithmetic sequences that we were given, we can see that we have Tn is equal to A plus N minus 1 D. Okay. If we rewrite that in a little different way, we get A plus D times N minus D. Okay, and then since this minus D and A are constants, so just numbers, we end up grouping them together. So this number here is A minus D, and this Dn would be this number here. So we can see we have D times N, here we have 7 times N. So if we have Dn is equal to 7n, we can just cancel the n's because it's not important right now. And we get D is equal to 7. Does that clear it up?
JT, please unmute so that we may know if you are satisfied with the answer. Okay, he has tapped yes.
Okay, so carrying on with this geometric series question, we are just carrying on, substituting in 1 minus R is going to be 1 minus a half. And then from that, we get that the sum here is equal to 63. So from here to here, I just put it into the calculator straight. Okay. Next up, we have infinite series. So up until this point for arithmetic series and geometric series, we've been adding up to a point. So in this example, we've added up to 30 terms. We've only added 30 terms. And in this example, we only added up 6 terms. But now, if we want to add up into infinity, most of the time, if we add, say, 10 plus 10 plus 10, all the way to infinity, the answer is going to be infinity. Okay, but there are some times when we add numbers up that it doesn't get to infinity. So, for example, if we're adding 1 plus a half plus 0.25, 0.125, on and on, you can see that these numbers are getting smaller. So we are adding an infinite number of numbers, but these numbers keep getting smaller. So it doesn't add any, it keeps adding more numbers to the decimal places, but it doesn't make this number significantly bigger each time. It makes it bigger by smaller and smaller and smaller amounts. And eventually these amounts are negligible. So you'll actually find that it converges to a number. So for example, 2. Okay, and we can do that only under certain circumstances. And these circumstances are when the series that we have converges, okay? And we know that the series converges when our ratio is between -1 and 1. Then we can find an answer that is not infinity for the series. For any other value of r, the series diverges, so it goes off into infinity. But we don't have to worry about those. We just have to worry about the converging cases. Okay, so we're given this example, so let's take a look at it. We're given 18 plus 16 plus 2, and so on. So the first thing we need to do is this geometric series, number 1, and does it converge, number 2? So we're going to see if there's a common ratio. So we just label these. This is T1, T2, and T3. And we're not given anything else. So T2 over T1, remember this is the test for a geometric sequence. So we have 6 over 18. That gives us 1/3. Then let's try term 3 over term 2. That is 2 over 6. And that also gives us 1/3. So we can say that yes, we have a geometric series and yes, r is between -1 and 1. So that means it's going to converge. And now that we know that this geometric series is going to converge, we can substitute all our values into this sum here. So this formula that we're given is S infinity. So that means the sum to infinity is equal to A over 1 minus R. Okay, so the A we know is our first term, T1, that's 18, and the R we've just worked out to be 1/3. So now we just substitute this in. A is 18. R is 1/3. And when we plug that into our calculator or work it out, we see that the sum is 27. Okay, so that is all the teaching for today. So if you want, we can have a 5-minute break if there's no questions. And then when we come back for the second hour, I'm going to go through some other questions. So here are the other questions. Some of them are easy, some of them are a bit harder. So there's a whole mix of difficulties. So are there any questions before we get onto those?
Part of the UKZN experience is the opportunity to be part of a community and to network with not only our world-renowned academics, but with future game changers and leaders. They do say that the extent of one's success can be attributed to those they rub shoulders with. Therefore, you must surround yourself with like-minded people. So, how do you become part of a community that is committed to your self-development? How do you become part of UKZN? First, you have to apply.
All applications for undergraduate studies at UKZN are processed through the Central Applications Office, CAO. This is for both your course and student residence application. The application process is as follows. Step 1. Consult the CAO handbook. This handbook provides a list of all qualifications available at UKZN. Step 2. Have a look through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom in accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westville. Then BCN stands for the actual course. Make sure to get these codes right. Step 4. Use this program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. You can always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za.
It's that easy. Pay close attention to closing dates for qualifications. For example, MBCHB closes on the 30th of June, whilst other undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
Okay, so I haven't seen any questions come through, so I'm going to assume that we can just carry on to the next questions. So question 1, we are given a sequence 6, 13, and 20. So the first question is to calculate the 21st term of the sequence. So it is asking term 21, what is that going to be? Well, we all know we could just keep adding 21 times until we get to the sequence, the term 21, but we have a simpler way. We need to, first of all, see what kind of sequence this is. Then from there we can find the general term and then substitute in 21. So step 1, what type of sequence is it? So let's see if there's a common difference first. So this is plus 7 and plus 7 as well. So this means first difference is constant. And from before, we know that this means we're dealing with an arithmetic sequence. Okay, so I'm pretty sure you'll be given all the formulas and stuff that you'll need, but it's better and quicker if you know the formulas off the top of your head. So here is the formula. Tn is equal to A plus n minus 1 times d. Okay, so here's A, the first term that we're given, plus n minus 1. We know n actually, it's 21. So we're finding term 21, and the common difference we found here, it is 7. I think actually, sorry about that. Let's find the general sequence first and then substitute in 21. So we're going to just leave n in. So we have 7n minus 7, and the general sequence is 7n minus 1. And now that we have that, it'll help us for the next question. So it's nice to just have it there, even though we could have just gone straight to this answer here that I've crossed out. So now let's substitute in T21, term 21, is equal to 7. The n is 21. We're looking for the 21st term, plus 1. And if we just work that out, sorry, that is minus 1. We get 146. So that is the 21st term. So if we carry on, somewhere we get 146, and then it carries on. That's T21. So next up, we are asked which term of the sequence is 97. So we're looking for n, because we know Tn, so we don't know what the n is equal to 97. So we're looking for what is n. So we have our formula here, so let's just write it out again. 7n minus 1. We know what Tn is. We know what the value at this term is, we just don't know where it is. So that's why we're looking for n. 7n minus 1. And then all we need to do is solve for n. So add 1 and then divide by 7. So 98 divided by 7 is 14. So n is equal to 14. Okay, remember you can stop me at any time for any question. I don't mind going back or repeating things. Okay. Question 2, we need to give, so we're given an arithmetic sequence, and it has some variables in it, so p. So we don't actually know what it is. We need to determine the value of p. So let's write out what we're given. 1 minus p, that's the first term. 2p minus 3 is the second term. And then p plus 5 is the third term. So where do we go from here? Well, we know it's an arithmetic sequence. And with arithmetic sequences, we know that the first difference is constant. So let's go from there. So this difference, we're just going to call it d. And this difference is the same. But how do we work out the difference? Well, if we just go back, we are given this formula. So d is equal to t2 minus t1 and t3 minus t2. And that's what we have. Here's t1, t2, t3. So if we write this out, d is equal to t2, which is 2p minus 3, minus t1, which is 1 minus p. Okay, we can just solve as much as we can. So remember to be careful with this minus when you're distributing it in. So we have minus 1 plus p. And we have 3p minus 4 equal to d. And d is also equal to t3, which is p plus 5, minus 2p minus 3. If we just distribute that out, p plus 5 minus 2p plus 3. It was minus p plus 8. And we can see that d is equal to p minus p plus 8, and d is also equal to 3p minus 4. So that means that we can equate these two. So let me just write this out again. 3p minus 4 and d is equal to minus p plus 8. So we can see that these two are equal. So 3p minus 4 equals minus p plus 8. If we just take the p's to one side, the constants to the other side, we get that p is equal to 3. And if you want to check that your answer is right, you can substitute p in here and make sure that the difference is common. And another way you could have done it is completely skipping using the variable d because we don't really need it, and just use this formula here. T2 minus T1 is equal to T3 minus T2. And then from there, you could have just substituted in each of the terms. So just substituted T1, T2, and T3 into here. And you'll get the same answer because it's pretty much the same working, just taking out this middle step using D. Okay, question 3 says, if the sequence 5, x, 45 are the first three terms of a geometric sequence. Determine the value of x. So we know that this is a geometric sequence. And now that we know this, there are two ways we can go about it. So first up, we can say 5 times r, we don't know what r is, 5 times r gets us to x, right? Because we're going to times by r and times by r, because it's a geometric sequence. And x times r gives us 45. Now we can solve for r. So keep r on one side. So r is equal to x over 5. And r is equal to 45 over x. Then we can just make these two equal. So x over 5 equals 45 over x. Then let's try to get all the x's on one side. So let's multiply both sides by x. So we get x squared over 5 is equal to 45. Let's then multiply both sides by 5 to get that 5 away. That gives us 225. Now, to get x, we just take the root on both sides, and we know that could be plus minus 25. So as you can see, we have two answers here. Five, 25, 45. 5 minus 25, 45. Okay, and the reason for this is our r could be equal to I think that shouldn't be 25, that should be 15. X is equal to plus minus 15. So our answers could be 15 or minus 15. Okay. And this is because our r could be equal to 3. So here we times by 3 and times by 3. Right? 5 times 3 is 15. 15 times 3 is 45. Or r could be equal to minus 3. 5 times minus 3 is minus 15. Minus 15 times minus 3 is 45. So that's a little trick just to watch out for. Yes, you're right, it is 15. Yeah, so just be mindful of the square root and rooting. Okay, then for the second way, I think it's a bit more intuitive. So you're given, just write this out again, 5x 45 times by r and times by r, you're going to get from 5 to 45. So we say 5 times r, that gets to x, times r gives us 45. So that means r squared is equal to none. And then that means R is equal to plus or minus 3. And then you just take 5 times 3 will give you 15 answer, or 5 times minus 3 will give you minus 15. Okay, so therefore x is equal to plus minus 15. And that's your answer. Okay, are there any questions so far? We've gone through 3 questions. Okay. So question 4 says, the sum of n terms, so an unknown number of terms, is given by Sn is equal to n plus 1 over 2, or n plus n squared over 2. Okay, so the question is, what is T5? So first off, I'm going to do the longer way that kind of explains the shorter way. So let's do it. So to start off, let's find out what S1 is. So we're just, wherever we see n, we're going to replace 1. So 1 plus 1 squared is equal to 2. Oh, sorry, 1 plus 1 squared over 2 is equal to 2 over 2, which is 1. And if you think about it, the first sum is just going to be T1. So there's nothing else. You're just adding one term, basically. So we can say that S1 is equal to T1. Okay, then let's carry on. If we add 2 terms, so the first 2 terms, then we're going to substitute in 2. So we have 2 plus 4 over 2 equal to 6 over 2, which is 3. And this equals term 1 plus term 2, right? Because we've added the first 2 terms up to get S2. We already know S1. So this tells us that T2 is equal to 2. So this is the long way. There is a shorter way, but this is just to kind of get the understanding first. S3, similar thing, 3 plus 9 over 2. Is 6, and that is also equal to T1 plus T2, so the sum of the first 3 terms. Okay, so we know that T3 is equal to 3, right? Because either you can add up T1 and T2, so this is 3, as we can see from the previous one. So we don't actually have to add up T1 and T2, because this sum right before it is T1 and T2 added together. So we're going to do this again. 4 plus 16 over 2 gives us 10. And S4 is T1 plus T2 plus T3 plus T4. So then what is T4? Right? We could add up all of these that we've worked out so far, or we could just look at S3 to find T4. So it's going to be 4. S5, 5 plus 25 over 2 is 15, and S5 is T1 plus T2 plus T3 plus T4 plus T5. So T5 could be 15 minus 1 minus 2 minus 3 minus 4, or we could just work out T5 to be, T5 is equal to S5 minus S4. They'll both give us the same answer. So hopefully by now you've seen that we could have just worked it out by saying S4, working out what that is. So substituting it into this formula here. Sorry about that, the camera paused. Okay, so I hope you're following along just by my voice, but I'm just going to quickly go through it again. So we worked out S1 from the formula, found out what T1 was, worked out S2, now we know what T1, T2 is, and so on and so on. We get to S4. S4 is the sum of T1, T2, T3, and T4. When we work out S5, it's the sum of T1, T2, T3, T4, T5. So the only difference here from S4 to S5 is that we've added T5. So instead of doing all of this working out, we could just find the difference between S5 and S4. So I'm just going to write this out again, even though we've already done it. It's 4 plus 16 over 2 is 20. S5 is 5 plus 25 over 2, which is, 20 over 2, which is 10. This is 30 over 2, which is 15. And now we know that T5 is equal to S5 minus S4. And since we know that, we can substitute in our values. 15 minus 10 gives us 5. Okay. So there's the, there's the long and the quick way to working out question 4. Question 5. The sum of the series 22 plus 28 plus 34 and so on is equal to 1,870. Determine the number of terms. So we're looking for n. We don't know what n is. So now the first step is to find out what kind of series this is. So first up, let's look at the difference. 22 plus 6 gives us 28. 28 plus 6 gives us 34. So we know that it is going to be an arithmetic series. And so we So we know that the formula is Sn is equal to n into 2a plus n minus 1 times d all over 2. So we're looking for n. We've been given Sn already. We know the sum. So let me just write this here. Sn is equal to 1,870. A, we know what that is. It is our first term, so 22. D, we have worked it out, is plus 6. Okay, so now we have everything we need to solve for n. So we just plug it all in. 1870, it's our sum. N, we don't know. 2 times A, we know is 22. Plus N, we don't know. D is 6. And we divide all of that by 2. Okay. Now we're just going to simplify this a little bit and then solve for n. Okay, so we can take the 2 over to the other side. So it becomes 3,740. N, the other side is N44 plus 6n minus 6. And then we multiply n. So 44 minus 6, that's 38. So we get 38n plus 6n squared is equal to 3,740. So now we can see this is going to be a quadratic that we're solving. So let's take everything to the one side. N squared plus 38n minus 3,740. Okay, this is a bit of a complicated one, so we're just going to use the quadratic formula. Minus b plus minus root b squared minus 4ac all over 2a. Okay, but instead of solving for x, we're just going to make it n. Okay. So okay, so our first answer that we get is 22. Or we may have a second answer. We get approximately negative 28.3. Negative 28,33 recurring. Okay, so there are 2 reasons why this answer won't work. Number 1, it's negative. And we know that the answer has to be at least greater than 3, okay? Even without doing any sums. And also, it's not a whole number. So that's that answer. Right, as you can see, we always go T1, T2, T3, etc. So there's never a 20 and a half term. Okay, so that is the reason why we can't use that. So just strike a line through it to say, nope, it can't be that one. So our answer is 23. Sorry, 22. Okay, on to question 6. What is the value of m for which the sum is 65? So let me just write out the sum nice and big. Sum k is equal to 1 up to m. 5 times 3 to the k minus 1 is equal to 65. So our question is, what is m? So normally it would be n, but in this case, we're just looking for m. It's simple swap of variables. Next, this is a sum. We can see from this part here that it is a geometric series. So we need to find a, and that is when k is 1. So a is t1. So we're going to substitute in 1. So 5 times 3 to the 1 minus 1 is equal to 5 times 1, because 3 to the 0 is just 1, which is 5. Then r is given. It's this 3. We can remember from that formula we learned earlier, Tn is equal to AR to the n minus 1. So we can see there's A and there's R. The next thing we need to do is, since we're working with sums, is remember our geometric series formula. So that is Sn is equal to A 1 minus R to the n over 1 minus R. I think in this case, it just needs to be M instead of M. So we're working with M here. Okay, so we're given the sum as well. Let me just write that down. The sum up until M is 65. So we can substitute that in as well. So 65 is equal to 5 into 1 minus 3 to the m over 1 minus 3. Just take this onto a new page. Okay, so this is minus 2, so we can multiply over by minus 2. We have minus 130 is 5 into 1 minus 3 to the n. Take the 5 across, is minus 26. It's equal to 1 minus 3 to the m. If we take the 1 across, we get minus 27 is equal to minus 3 to the m. We can take the negatives away, and we can make this into exponential form. So 27 is 3 to the 3, and it is equal to 3 to the m. So the bases are the same, so we can just drop them, and we find that m is equal to 3. Okay, are there any questions so far about anything that we've gone over? On to question 7. We are given an interesting sequence of a half, 4, a quarter, sorry, 7, 1/8, and 10, and then it carries on. So at first glance, this may seem like some kind of sequence that we've never seen before, very difficult, but after a bit of closer inspection, we can see that every odd term, so a half, a quarter, and an eighth, that looks kind of like a geometric series. And 4, 7, and 10 kind of looks like an arithmetic series. So what we can do is just separate them out, just for us to understand it a little bit easier. So just remember, this is term 1, term 3, and term 5, okay, of this original sequence. And we can see that we are multiplying by a half each time. So that means r is equal to a half, and this is in fact a geometric series. Okay, and then if we look at the even part of the sequence, 4, 7, 10, so T2, T4, T6 of the original sequence, we add 3 each time. And that means that this has a common difference of 3, and it is arithmetic. Okay, so we have 2 series that are kind of spliced together. So our goal then is to write down the next 2 terms. So we have T1, 2, 3, 4, 5, 6, 7. The next one we need is 7 and 8. So T7 comes from this geometric series. So we need to multiply 1/8 by 1/2. That gives us 1/16. Then for T8, we need to look at this arithmetic sequence, and we need to add 3. So we get 13. So those are the next 2 terms in the sequence. And then the next question asks, to calculate the sum of the first 50 terms of the sequence. And since we know that it's a mixture of geometric and series, and they alternate, we can work out the first 25 of this sequence and the sum of the first 25 terms in this sequence. And if we just add it together, it's the same as adding them like that. So in case it's not clear, let's just take a look at the first 6 as an example. So this is the same as a half plus a quarter plus an eighth plus 4 plus 7 plus 10. Okay, so if we split it up into their respective series, we can work them out separately and then add them together. Since we don't know a formula for this mess, but we know a formula for a geometric series and a formula for an arithmetic series. So let's get our formulas and go. So I'm going to do the geometric one first, and I'm just going to label it. So geometric series, half plus quarter plus an eighth. Okay, so what is the information we need to know? We don't know what SN is. That's what we're trying to figure out. We know we want half of 50, right? Because we need to calculate the sum of the first 50 terms, and that means half of them are going to be geometric. So we're going to work out 25. So that's N. We know A is a half. That's our first term in the sequence. And we already know R is also a half. Okay, so we just need to write out the formula. Sn is equal to A 1 minus R to the N over 1 minus R. I'm just going to do it on one line for space. And then for N, we know a half. 1 minus a half to the power of 25 over 1 minus a half again. Is equal to okay, and just by the way, no, sorry. Okay, so the answer is, if we round it off, it's going to be 1. So we have 1 for the geometric series. So that's half of them done. Now we need to do the arithmetic series. So that is going to be 4 plus 7 plus 10 plus up to 25. So again, we don't know what the sum is because that's what we're trying to work out. We know that we need to add up 25 of these terms. We know we start at 4. And the common difference that we worked out is plus 3. Then what we need is our formula. Sn is equal to n 2a plus n minus 1 d 4 over 2. Then we substitute in everything we know. Don't know Sn. N is going to be 25. 2 times 4 plus 25 minus 1 times 3 all over 2. And that gives us 1,000. So now we've added up all of the geometric series and all of the arithmetic series. So all we need to do is find the total sum now. So we have 1 and 1,000. So total sum is 1,000 plus 1, which is simply 1,001. Okay, does everyone get why we split up this series and why we use 25? And are there any questions? Okay. So next up we have question 8. Simply says, calculate the sum to infinity of sum from p is equal to 1 to infinity of 8 times 4 to the 1 minus p. Okay, so this doesn't really look like the standard form that we're used to. So let's write it out another way. Sum from p is equal to 1. So p is going to be our n. Okay. P is equal to 1 to infinity 8. And here we have 4 to the 1 minus p. And we know that if we flip this and distribute a minus 1 into it, it will be equal. So 1 over 4 is equal to p minus 1. And that looks more like our standard form that we have here. We have a times r to the n minus 1. So the minus 1 is at the end. There we go. So now we can write that 1 over 4 p minus 1. And now that we have it in our standard form, we can see r is equal to 1 over 4. And this means that 1 is greater than minus 1. Sorry, r is greater than minus 1 and less than 1. Therefore, we can use the formula for the sum to infinity. Next, we have a. We need to find it's 8 from our standard form. You can just read it straight off there. And that's all we need for this formula. So let's write down the formula. Sum to infinity is equal to a over 1 minus r. So that is 8 over 1 minus a quarter. And that gives us 32 over 3, which if you want to round it off is about 10,67. Then. Okay, so I'm going to skip question 9. Sorry. Because it's a little bit too difficult and we haven't done any quadratic examples yet. So on to question 10. So we're given this simple sequence of 10, 7, 5, 4, 4. Okay. First thing we need to do is find out what kind of sequence it is. So let's do that. 10 minus 3 gives us 7. 7 minus 2 gives us 5. 5 minus 1 gives us 4. 4 plus minus 0, whatever you want, gives us 4 again. And let's look at the second difference. Minus 3 plus 1 is minus 2. Minus 2 plus 1 is minus 1. Minus 1 plus 1 is 0. Okay, so we know that it is quadratic. So now we need to find Tn. Okay, so there's many different ways to do this, but I'm just going to use my way. And if you have a different way that works better for you, then you use that one. Okay, so let's just give the general form. Tn is equal to an squared plus bn plus c. So I'm going to find c by working backwards. Okay, so if we take 1 away from -3, that's going to be -4. So 10 plus 4 must have been 14. Okay. And just to make sure, let's just check it out. Okay, so here we have -4, -3, and the difference you can see is +1. So we know that we should be correct about our value for t is equal to for t0. And then we have 2a is equal to this second constant difference, which is 1. So a is equal to 1/2. Then we're going to use these values to find out what b is. The easiest value to substitute in is when n is equal to 1. So to write out this general formula again. Okay, so now we're going to substitute in n is equal to 1. So t1 is equal to 10. A is 1/2. N is 1. B times 1 plus 14. So then we have 10 minus 14 minus 1/2. So B is going to be equal to -9/2. And then we can now write this out in full. So we have 1/2 n squared minus 9/2 n plus 14. Question B says find the 10th term of the sequence. Just going to write this out again. Substitute in n is equal to 10. So we're looking for T10. So 1/2 times 10 squared minus 9/2 times 10 plus 14. And I believe that gives us that Tn is equal to 19. Next, we have a quadratic number pattern. Question 11. 4 P 11 Q 22. And we're told that it has a constant second difference of 1. Now we need to show that P is equal to 7 and Q is equal to 16. Okay, so what we can do here is, so this is the first difference, right? So it's here. Then, okay, let me just put that there. 11 minus P, that's the first difference. Q minus 11 and 22 minus Q. So those are all our first differences. Then the difference between these is 1. We know that because that's what we were given in the question. So we can use this here to find out what P is. So if we just look at another concrete example, what we do is the second term minus the term before it equals this one. Okay, so this term, this -2 minus -3 gives us +1. So that's the logic we're going to apply to this question here. So we're going to take this 11 minus p. We're going to subtract p minus 4, and we know that equals 1. Forget the brackets. Yeah, so we have 11 minus p plus 4 is equal to 1. So minus 2p is going to be equal to minus 14. So p is going to be equal to 7. If we look back at the question, show that p is equal to 7. So we know we've got that right. Then I'm just going to do it on this side because it's base. We're going to do the same thing to work out q. So we're going to take the second value here, 22 minus q. We're going to minus it from the one before it, so q minus 11 is equal to 1. So we get 22 minus 2q plus 11 gives us 1 minus 2q, going to give us minus 32, and q is going to be equal to 16. And we needed to show p is equal to 7 and q is equal to 16. And as you can see, that's what we've done. Okay, so this was A. To question B. We need to determine the general term Tn of the quadratic pattern. So first thing is the same like always, we write down the general form and we're going to look for T0. So we have 4, 7, 11, 16, 22. P is 7, so this difference is going to be, oh wait, sorry, 3, 4, 5, 6. So then the difference here must be 2 plus 2, so this must have been 2, right? 2 plus 2 is 4, so we know that C must be equal to 2. And 2a is equal to the common difference, common second difference. There we know it's minus 1, so we know it's 1, so a is equal to a half. Now we know C and A, so we can substitute in T1 is equal to a half, 1 squared plus B times 1 plus 2. T1 is here, it is 4, so 4 is equal to a half plus B plus 2. So B is equal to 3/2. Yeah. Okay. Then we write down write down our answer in full. And there we have it. Now C, the last question of today, is determine the value of n. Oh, second to last. Okay. Determine the value of n if Tn is equal to 232. So write down the formula that we've worked out. Here we know that the value of Tn is 232. So now we just need to substitute that in. Now I'm just multiplying through by 2. And I'm just going to quickly put this into the calculator, into the quadratic equation. So we get that n is equal to 20. Or n is equal to minus 23. And we already know that this can't be an answer because we are looking at the positives. So it's going to be somewhere here. We know it can't be negative, no negatives. Okay, I think that's actually all the time we have for today. Yeah, so thank you all for joining. I hope you learned something and I'll see you at the next session. Also, before you go, please don't forget to sign the register.
Rachel, can I now stop the recording?
Yes.